Development timeline for carrier-based drone operations, 3 key milestones leading to full operational capability by late 2024. Introduction. The evolution of carrier-based drone operations is a significant shift in modern military strategy, emphasizing the need for advanced aerial capabilities in a rapidly changing global landscape. As nations strive to enhance their defense mechanisms, the Canadian Armed Forces CAF have embarked on a transformative project aimed at integrating MQ-9B drones into their operations. This report outlines the key milestones leading to the establishment of full operational capability by late 2024, with a focus on the implications for military strategy and operational effectiveness. Key milestones. 1. Initial development phase 2023, early 2024. The journey towards operationalizing carrier-based drones began in December 2023. When the Canadian government awarded a $2.5 billion Canadian dollars contract to acquire MQ-9B drones tailored for Arctic operations. This decision was grounded in the recognition of the strategic importance of maintaining a robust defense presence in the Arctic given increasing geopolitical tensions and environmental challenges in the region. Construction of the first 2 drones commenced in early 2024 at a facility in San Diego, California. This phase also involves establishing the necessary infrastructure to support drone operations, including 6 ground control stations and logistical support systems. The commitment to develop a comprehensive operational framework reflects a significant investment in enhancing Canada's military capabilities. 2. Operational testing phase 2026. Following the initial production phase, the operational testing of the MQ-9B drones is scheduled to begin in 2026, with the first delivery of the drones expected in 2028. These drones are equipped with advanced technologies essential for long-range intelligence surveillance and reconnaissance ISR missions. The integration of the Lynx multi-mode radar and electro-optical/infrared sensors showcases the drone's versatility and operational readiness for various environments, including the challenging Arctic conditions. The operational testing phase will be critical in assessing the performance of the drones in real-world scenarios, ensuring that they meet the rigorous demands of military operations. Successful testing will pave the way for their deployment in both domestic and international operations, enhancing Canada's capabilities in border surveillance, disaster response, and reconnaissance missions. 3. Full operational capability late 2024 to 2033. The goal is to achieve full operational capability for the MQ-9B drones by late 2024, however this timeline has faced adjustments due to the complexities involved in integrating advanced drone technologies into existing military frameworks. Initially, full operational capability was anticipated by 2030 to 2031, but the revised timeline now extends to 2033. Reflecting the ongoing challenges associated with adapting the drones for Arctic conditions. This extended timeline highlights the intricate nature of modern military acquisitions, where technological advancements must align with operational needs and strategic objectives. The successful integration of the MQ-9B drones into the CAF will mark a significant milestone in enhancing Canada's defense capabilities and sovereignty. Common key points. The strategic importance of the MQ-9B drones is underscored by their multi-role capabilities, which include ISR and potential strike operations. These capabilities are crucial for both national security and international missions. Dedicated infrastructure to support drone operations is essential, illustrating the logistical challenges associated with advanced military systems. The long-term vision for the MQ-9B program emphasizes Canada's commitment to strengthening its defense posture, particularly in the Arctic region. Differences between sources. Source 1 focuses on the broader implications of unmanned aerial systems (UAS) in modern warfare, addressing the cost, time, and capability trilemma faced by operators. Source 2 provides specific details regarding the CAF's acquisition of MQ-9B drones, including production timelines and operational capabilities, while also highlighting challenges and delays. Source 3 was inaccessible, limiting the breadth of insights into the drone operations timeline. Complete timeline of events. December 2023, the Canadian government signs a $2.5 billion Canadian dollars contract for the MQ-9B program. January 2024, production begins on the first two MQ-9B drones at a U.S. facility. 2026, operational testing of MQ-9B drones is scheduled to begin. 2028, the first delivery of the MQ-9B drones is expected. Late 2024, aiming for full operational capability, although this is subject to delay. 2033, revised date for full operational capability following technical complexities and adaptations. Conclusion. The development of carrier-based drone operations represents a transformative shift in military strategy, underscoring the need for advanced aerial capabilities in addressing contemporary security challenges. The Canadian Armed Forces' commitment to integrating MQ-9B drones into their operations reflects a strategic vision for enhancing national defense, particularly in the Arctic region. As the timeline progresses towards full operational capability, the complexities of technological integration and logistical support will play a pivotal role in shaping the future of military operations. This evolution highlights the interplay of innovation strategy and operational readiness in the modern defense landscape, positioning Canada to meet the demands of a dynamic and evolving security environment. The development timeline for carrier-based drone operations, specifically the Canadian Armed Forces CAF acquisition of MQ-9B drones, showcases several counterintuitive elements regarding military technology integration and operational capabilities. Here are some key points that highlight this counterintuitive information. 1. Delayed full operational capability despite early investments. Initially, the goal was to achieve full operational capability for the MQ-9B drones by late 2024. However, the timeline has been stretched to 2033 due to technical complexities and necessary modifications for Arctic operations. This delay contrasts with the expectation that significant financial investment, $2.5 billion Canadian dollars, and early contracts would accelerate operational readiness. It illustrates a common paradox in military procurement: substantial upfront investment does not guarantee timely delivery of capabilities. 2. Integration challenges over technological advancements. While the MQ-9B drones are equipped with advanced technologies such as multimode radar and electro-optical/infrared sensors, the integration of these technologies into existing military frameworks has proven more complex than anticipated. This counterintuitive aspect emphasizes that technological superiority does not automatically translate into operational readiness. The military often faces hurdles in adapting new technologies to fit within established operational structures, which can lead to unexpected delays. 3. Infrastructure development versus drone production. The construction of 6 ground control stations and a centralized control facility in Ottawa is crucial for the operational success of the MQ-9B program. Interestingly, while physical drone production is underway, the development of necessary infrastructure has not kept pace. This highlights a counterintuitive situation where the need for comprehensive support systems is often underestimated in parallel with technological advancements. 4. Arctic operations as a double-edged sword. The emphasis on adapting drones for Arctic operations may seem straightforward given Canada's geographic considerations. However, this focus has introduced additional layers of complexity in design and integration, which were not fully anticipated at the project's inception. The assumption that drones could simply be modified for different operational environments has proven too simplistic. This counterintuitive realization underscores the need for comprehensive planning that considers diverse operational challenges from the outset. 5. Public transparency versus security concerns. The Canadian Department of National Defence (DND) initially cited security concerns regarding the location of the control centre, which was later contradicted by publicly available documents. This inconsistency raises questions about transparency and the handling of sensitive information within military projects. It indicates that military organizations may often operate under the assumption that security necessitates secrecy, yet this approach can backfire and lead to public distrust or miscommunication. 6. Strategic importance versus operational reality. While the MQ-9B drones are touted for their strategic importance in enhancing national defense capabilities, particularly in the Arctic, the reality of their operational timeline paints a different picture. The expectation that these drones would offer immediate strategic advantages is tempered by the lengthy timeline required for full operational capability. This discrepancy reveals a counterintuitive situation where strategic aspirations may outpace practical realities, leading to a gap between expectation and execution. 7. Multi-role capabilities versus focused implementation. The MQ-9B is designed for various roles including ISR and potential strike operations. However, the practical implementation of these multi-role capabilities may face hurdles in operational doctrine and execution. The assumption that drones can seamlessly transition across various mission types may overlook the intricacies of military operations where specific training and procedures are needed for different roles. In summary, the development of carrier-based drone operations within the CAF highlights several counterintuitive aspects, including delayed timelines despite investments, integration challenges versus technological advancements, and the complexities of adapting to specific operational environments. These factors underscore the often overlooked realities of military technology development and the need for comprehensive planning and execution strategies to bridge the gap between aspiration and operational capability. In examining the report on the development timeline for carrier-based drone operations, particularly concerning the Canadian Armed Forces acquisition of MQ-9B drones, several important aspects are likely to be overlooked by many readers. These details, though seemingly minor, carry significant implications for military strategy, operational effectiveness, and international relations. 1. Infrastructure development, the backbone of drone operations. While the report highlights the acquisition of drones and their capabilities, the emphasis on the establishment of dedicated infrastructure such as ground control stations is critical yet underappreciated. The construction of 6 ground control stations, along with the associated logistical support, demonstrates a comprehensive approach to integrating drone operations into the military framework. The significance of this infrastructure cannot be overstated. Proper command and control facilities are essential for effective ISR operations, allowing for timely data analysis and mission execution. The planned military facility in Ottawa, expanded to accommodate nearly 200 personnel, indicates a serious commitment to operational readiness. This infrastructure is not just about flying drones, it's about establishing a robust operational ecosystem capable of supporting complex missions in diverse environments, particularly in the challenging Arctic conditions. Moreover, the logistical aspect of drone operations, including maintenance and personnel training, is often overlooked. The requirement for specialized training for operators and support staff to handle advanced drone technologies and the associated systems is paramount. This aspect ensures that the drones can be utilized to their full potential, thus enhancing overall mission success rates. 2. The technical complexities of Arctic adaptation. Another critical detail that may escape the attention of many is the specific adaptations needed for drone operations in Arctic conditions. The report mentions that modifications to the MQ-9B drones are necessary for them to function effectively in such an environment. This adaptation process highlights the inherent challenges of operating advanced technologies in extreme conditions. The Arctic presents unique challenges, including extreme temperatures, limited visibility, and harsh weather conditions, which can complicate both drone operation and data collection. The fact that the timeline for full operational capability has been pushed back to 2033 due to these complexities underscores the importance of not only the technology itself but also the environmental factors that can affect military operations. Understanding these adaptation requirements is significant because they reflect the broader implications for military readiness and capability. As nations increasingly focus on Arctic operations due to geopolitical interests and climate change, the ability to effectively deploy drones in such environments will be a critical factor in maintaining strategic advantages. 3. Integration challenges with existing military frameworks. The report notes that the integration of MQ-9B drones into existing military frameworks is complex and fraught with challenges. This point is crucial because it highlights the broader issue of how new technologies are assimilated into traditional military structures. Many defense organizations struggle with the integration of unmanned systems, which often requires not just technological adjustments but also shifts in operational doctrine, training protocols, and command structures. The delays in achieving full operational capability reveal the potential pitfalls of rushing into new technologies without adequate planning and adaptation of existing frameworks. This aspect is significant because it illuminates the need for comprehensive change management strategies within military organizations. As unmanned systems become more prevalent, understanding how to integrate these systems effectively into established military operations will be critical for success and operational efficiency. 4. Strategic importance of ISR capabilities. While the report mentions the MQ-9B's capabilities for intelligence, surveillance, and reconnaissance ISR, the strategic implications of these capabilities are often understated. The emphasis on long-range ISR capabilities reflects a growing recognition of the need for enhanced situational awareness in modern warfare. As geopolitical tensions rise, the ability to conduct ISR missions over vast and remote areas, particularly in the Arctic, becomes increasingly vital. This capability allows for better monitoring of potential threats and supports strategic decision-making processes. Furthermore, the potential for strike operations adds another layer of operational versatility, enabling military forces to respond more effectively to emerging threats. The strategic value of ISR capabilities is significant because it not only enhances national defense but also contributes to international stability. Enhanced ISR capabilities allow nations to participate more effectively in multinational operations, fostering collaboration and shared intelligence among allies. 5. International partnerships and technology transfer. The report briefly touches on the international partnerships involved in the project, yet the implications of these collaborations are profound. The involvement of General Atomics, a US-based company, in the production of MQ-9B drones for Canada highlights the critical role of defense industrial collaboration in enhancing military capabilities. Such partnerships can facilitate technology transfer, allowing the Canadian Armed Forces to benefit from advanced US drone technologies and operational practices. This aspect is significant because it indicates a move toward greater interoperability between allied forces, particularly in the context of joint operations in regions like the Arctic where multiple nations have strategic interests. Moreover, these international partnerships can enhance Canada's defense posture by ensuring access to the latest technologies and innovations, which are crucial for maintaining a competitive edge in military capabilities. Conclusion. In summary, the report on the development timeline for carrier-based drone operations provides valuable insights into the complexities and challenges associated with integrating advanced drone technologies into military operations. The importance of infrastructure development, the technical challenges of Arctic adaptations, the intricacies of integration with existing military frameworks, the strategic value of ISR capabilities, and the implications of international partnerships are critical points that readers may overlook. Understanding these elements is essential for grasping the broader implications of military drone operations, especially in the context of evolving geopolitical landscapes and the increasing significance of unmanned systems in modern warfare. As nations navigate these challenges, the lessons learned from the Canadian Armed Forces MQ-9B program will likely inform future developments in military drone operations worldwide. 1. Strategic importance of MQ-9B drones. the MQ-9B drones represent a significant advancement in military capability, particularly for the Canadian Armed Forces. Their design for Arctic operations highlights the growing need for nations to enhance their surveillance and reconnaissance capabilities in increasingly contested regions. These drones not only serve domestic security roles but also bolster international defense and reconnaissance missions. Their multi-role capabilities, including potential strike operations, underscore their importance in modern warfare, particularly as geopolitical tensions rise and the need for effective ISR intelligence surveillance and reconnaissance expands. 2. Infrastructure and logistical challenges. The establishment of infrastructure necessary for operating these advanced drones is a critical aspect of their integration into military operations. This includes the construction of 6 ground control stations and a centralized military facility in Ottawa, which reflects the logistical complexities associated with deploying such advanced systems. The delayed timelines for both the completion of infrastructure and the full operational capability due to the need for modifications for Arctic conditions highlight the significant challenges faced in integrating new military technologies into existing frameworks. Understanding these logistical hurdles is essential for assessing the overall readiness and effectiveness of drone operations. 3. Timeline adjustments and technical complexities. The original timeline for achieving full operational capability by late 2024 has been revised to 2033 due to the complexities involved in adapting the MQ-9B drones for Arctic conditions and integrating them within existing military structures. This delay not only affects operational readiness but also reflects the broader challenges that come with advanced military technology development, including budget constraints, technical obstacles, and the need for thorough testing and evaluation. A detailed analysis of these timeline adjustments can provide insights into the realities of defense procurement and development processes. 4. International collaboration in military modernization. The acquisition of the MQ-9B drones is part of a broader strategy for military modernization within the Canadian Armed Forces, emphasizing the importance of international partnerships and proven technological advancements. The collaboration with General Atomics for the MQ-9B program illustrates how nations are increasingly relying on international defense partnerships to enhance their capabilities. Additionally, the focus on developing systems that meet NATO standards and can operate in conjunction with Allied forces is crucial for maintaining operational interoperability. Examining the implications of such collaborations can shed light on the future landscape of military operations and defense strategies globally. 1. Development of the U.S. Navy's Unmanned Combat Air System UCAS X-47B. The X-47B program marked a significant milestone in the development of carrier-based unmanned aerial vehicles (UAVs) for the U.S. Navy. Initiated by Northrop Grumman, the X-47B was designed to demonstrate the feasibility of unmanned operations from aircraft carriers. Key milestones included successful autonomous takeoffs and landings on a carrier in 2013, showcasing the potential for integrating drones into conventional naval operations. The program underscored the strategic importance of UAVs in enhancing maritime operational capabilities, paving the way for future developments in carrier-based drone technology. 2. The Global Hawk UAV program. The Northrop Grumman RQ-4 Global Hawk is a high-altitude, long-endurance unmanned aerial vehicle designed for surveillance and reconnaissance missions. The program began in the early 1990s and achieved significant milestones, including its first flight in 1998 and subsequent deployment in military operations post-9/11. The Global Hawk's ability to provide real-time intelligence and situational awareness has transformed military operations, highlighting the importance of UAVs in modern warfare. Its integration into various military branches and its operational use in conflicts such as Iraq and Afghanistan demonstrate the increasing reliance on unmanned systems for strategic military objectives. 3. The U.S. Air Force's MQ-1 Predator program. The MQ-1 Predator UAV program began in the mid-1990s and became a vital asset for the U.S. military in surveillance and precision strike missions. The Predator achieved its first combat success in 1999 during the Kosovo War, showcasing its capabilities in real-time intelligence gathering and targeted strikes. The program evolved through various milestones, including the introduction of armed variants which expanded its role in combat operations. The Predator's operational history underscores the effectiveness of UAVs in modern warfare, influencing military strategy and tactics while paving the way for the development of more advanced systems such as the MQ-9 Reaper. Future outlook: predictions for carrier-based drone operations. The advancement of carrier-based drone operations, particularly with the Canadian Armed Forces CAF integration of MQ-9B drones, signals a significant shift in military strategy and capabilities. As we look toward late 2024 and beyond, several predictions can be made regarding the future of these operations, driven by technological advancements, geopolitical factors, and strategic defense needs. 1. Enhanced operational capabilities. Integration of advanced technologies. By late 2024, MQ-9B drones are expected to incorporate cutting-edge technologies that enhance their operational capabilities. The integration of artificial intelligence (AI) for autonomous decision-making, machine learning for predictive analytics, and advanced sensor technologies will significantly improve ISR intelligence, surveillance, reconnaissance capabilities. This will allow for real-time data analysis and rapid response to threats, making these drones invaluable assets in various military operations. Multi-role functionality. The MQ-9B's design allows for multi-role functionalities, including ISR, electronic warfare, and even potential strike capabilities. As these drones become fully operational, their ability to adapt to different mission profiles will lead to increased versatility on the battlefield. The modular design will facilitate quick reconfiguration for specific tasks, allowing operators to respond dynamically to changing operational requirements. 2. Strategic military shifts. Focus on Arctic operations. The challenges posed by climate change and the increasing geopolitical interest in the Arctic region will drive a heightened focus on Arctic operations. The MQ-9B drones specifically designed for such environments will play a crucial role in monitoring and securing Canada's northern borders. As tensions rise in the Arctic due to resource exploration and territorial claims, the operational capabilities of these drones will be pivotal in establishing a strong military presence. Increased international collaboration. Canada's investment in MQ-9B drones is likely to foster greater collaboration with allied nations. As NATO and other defense partnerships evolve, the sharing of drone technology, intelligence, and operational strategies will become commonplace. Joint exercises involving carrier-based drone operations will enhance interoperability among allied forces, leading to a more cohesive military strategy against common threats. 3. Logistical and infrastructure developments. Expansion of ground control infrastructure. By late 2024, the establishment of dedicated infrastructure to support drone operations will be critical. The construction of ground control stations and associated facilities will enable efficient operations and training. This infrastructure will not only support the MQ-9B but also lay the groundwork for future drone systems, creating a robust framework for unmanned operations within the CAF. Challenges in logistics and maintenance. As the operational complexities of drone warfare grow, so too will the logistical challenges. The need for specialized maintenance training for personnel and the establishment of supply chains for drone-related technologies will be significant. Future operations may face delays or operational limitations due to logistical hurdles, necessitating a proactive approach to address these issues. 4. Evolving military doctrine. Shift toward unmanned warfare. The integration of the MQ-9B drones may signal a larger shift in military doctrine towards unmanned warfare. As operational capabilities expand, military strategies will increasingly incorporate drones into core operational plans, emphasizing their role in reducing human risk and increasing operational effectiveness. This shift may influence training budget allocations and the development of new tactics and strategies in modern warfare. Focus on cybersecurity and countermeasures. With the rise of drone technology, the need for robust cybersecurity measures will become paramount. As drones become integral to military operations, protecting them from cyber threats will be a top priority. Future strategies will likely include the development of counter-drone technologies to neutralize threats posed by adversaries, ensuring that drone operations remain secure and effective. 5. Global implications. Geopolitical tensions. The deployment and operational capabilities of the MQ-9B drones will have implications beyond Canada's borders. As nations invest in drone technology, regional tensions may escalate, particularly in contested areas such as the Arctic and other strategic regions. The presence of advanced drone systems may provoke reactions from rival nations, leading to an arms race in drone technology and capabilities. Impact on humanitarian operations. In addition to military applications, MQ-9B drones can also be utilized for humanitarian missions, disaster response, and surveillance of large-scale events. This dual-use potential may enhance Canada's international reputation and foster collaborations in peacekeeping and disaster relief efforts, showcasing the versatility of drone technology in both military and civilian contexts. Conclusion. The future of carrier-based drone operations, particularly with the deployment of the MQ-9B drones by the Canadian Armed Forces, holds significant promise. As we approach late 2024 and beyond, the fusion of advanced technologies, strategic military shifts, and evolving logistical frameworks will redefine military operations. While challenges remain, the potential for enhanced capabilities and international collaboration positions these drones as a transformative force in modern warfare, shaping the future landscape of defense strategies and geopolitical interactions.